Hello dear students, we know the solution of a non-homogeneous differential equation contains two parts, complementary function yh and particular integral yp. Today I am discussing a new method for finding the particular integral yp of a non-homogeneous ordinary differential equation, and the new method is called the method of undetermined coefficients. Method of undetermined coefficients. You consider the second order ordinary differential equation. ODE means ordinary differential equation, which is non-homogeneous. That is y double dash plus pxy dash plus qxy is equal to f of x, where f of x not equal to 0. Why we have this condition? We know when f of x equal to 0, then this differential equation becomes homogeneous. So now we are considering a non-homogeneous ordinary differential equation, and let me denote this by equation star. We know the general solution of this differential equation is y is equal to yh plus yp, where yh is the solution of homogeneous equation, that means f of x equal to 0, and yp is the particular integral. So yh is can be written in the form c1y1 plus c2y2, that already I discussed in the earlier class. One method of finding yp is the method of undetermined coefficient. But for all the non-homogeneous differential equation cannot be solved by the method of undetermined coefficient. There is a restriction for the coefficients. Here, more precisely, this method is suitable for solving linear ODE with the constant coefficient. See, the underlines word constant coefficient. So the method of undetermined coefficients can be suitable only for differential equation with constant coefficient that we are discussing here. Consider y double dash plus ay dash plus by is equal to f of x. See the coefficient of y dash is a and coefficient of y is b. A and b are constants, and f of x means it is a function of x. I put it as equation 1. Okay, so this is a non-homogeneous ordinary differential equation with constant coefficient, and I am discussing how to solve this differential equation, how to find yp of this differential equation by the method of undetermined coefficient. And this method is applicable when f of x is in a particular manner. That means this is used for when f of x is exponential function, that means some e raised to ax form, and x raised to n some algebraic functions, cos ax or sin ax, these are two trigonometric functions and their sum or products. And you can see this is very important. This method of undetermined coefficient is applicable only when f of x takes one of these forms or their linear combination, sum or products. Already we discussed in the previous class when how to find yp when f of x takes different forms. So in a similar manner, this method is also applicable when f of x takes one of these forms or the linear combination of these forms or sum or products of these functions. In this method, we choose yp similar to f of x but unknown coefficients to be determined by substituting yp and its derivative in the ODE. That means we are selecting yp according to a table. I will give you one table in the next page. So from the table you can select yp. It contains few unknown coefficients. Okay, so based on the function f of x given, you have to select yp from the table that contains some unknown coefficients that we should find separately. That is why I wrote here the unknown coefficients to be determined. That's why this method is called method of undetermined coefficient. So you select yp according to the function f of x given, find its derivative yp dash or yp double dash, whatever contains in your differential equation. You calculate yp dash and yp double dash and substitute in the given differential equation. The procedure. If f of x is not a member of the solution set, then choose pi, that means yp, from the table below depending on the nature of f of x. See the word, if f of x is not a member of the solution set. So what is solution set? Solution set means it is yh that we already calculated. Yh means it is a complementary function. So if your given f of x is not a member of that solution set, you can select yp from the below table. Now look at the table. The term in f of x, choice for ypx. Suppose your f of x is some k e raised to ax, some exponential function. Now you choose yp as some c e raised to ax. Same e raised to x, but the coefficient is c, some constant. Okay. Now suppose your f of x is some k sin ax or k cos ax. You select the yp as a sin ax plus b cos ax. Here we are introducing two constants a and b that we should find later. Okay. Now the third form. Suppose your f of x is k e raised to ax sin bx or k e raised to ax cos bx. If any one of these forms, suppose your f of x is any one of these forms, then you choose yp as a times e raised to ax sin bx plus b times e raised to ax cos bx. You find a and b later. Okay. Now come to algebraic function. Kx raised to n for n from 0, 1, 2, etc. If your f of x is an algebraic function, then you select your yp as k0 plus k1x plus etc. knx raised to n. This is the yp you have to select and then find k0, k1 etc. kn separately. Okay. Now come to the combination, the product of x raised to n into e raised to x. Suppose your f of x is some k times x raised to n into e raised to ax. Then you select yp as e raised to ax into k0 plus k1x plus etc. knx raised to n. This is the fifth form. Now come to sixth form. Suppose it is k times x raised to n sin ax, x raised to n sin ax. So it is a combination of the two yp's that we are writing in a particular manner. a0 sin ax plus b0 cos ax plus a1x sin ax plus b1x cos ax plus etc. an x raised to n sin ax plus bn x raised to n cos ax. So, in order to do with method of undetermined coefficient, you have to learn this table by heart. You learn this table, okay? And here k, c, a, b, etc. There are few constants that these are the constants that we'll find later. After selecting yp from the previous table, substitute yp in the ODE, then equate the corresponding coefficients. See, for finding the unknown coefficient, the constants, we are equating the corresponding coefficients. On LHS, we are substituting yp dash and yp double dash. RHS, in the given equation, we have some f of x. So then you equate the corresponding coefficient, then we get the values of the constants. But there is an important limitation. See the limitation. This method of undetermined coefficient does not work for linear equation with variable coefficient. Variable coefficient, we know it is Euler-Cauchy's equation. In that equation, the coefficients are variables. So this method does not applicable for differential equation with variable coefficients. Now for selecting YP, there is a choice rule for method of undetermined coefficient. We can't select any f of x from the table. There is a rule called choice rule. See the basic rule. The first rule is called the basic rule. Basic rule says that if f of x is one of the functions in the first column of our table, then choose yp in the same line and determine its undetermined coefficients by substituting yp and its derivatives in the ODE. If f of x is one of the function exactly same as the first column of our table. Suppose your f of x is exactly same as the first column of our table, then you can select the same yp as in the given table. That is the first rule called the basic rule. Now the second rule is modification rule or modified rule. If a choice of yp happens to be a solution of homogeneous ODE corresponding to the homogeneous differential equation, then multiply yp by x or by x square if solution corresponds to double root of auxiliary equation of homogeneous ODE. That means suppose your yp, we selected, suppose from the table we selected yp, that is one of the term in our complementary function. If our selected yp contains the same term in the complementary function, then what you have to do is you multiply the selected yp by x if the function has whose roots have multiplicity 1, or you multiply the selected yp by x square if that is a double root. The roots of that equation is double. Then multiply yp by x square. And this will be very clear when we are doing few problems based on this concept. Now the third rule, the sum rule, that says that if f of x is a sum of functions in the first column of table, choose yp as sum of functions in the corresponding lines of second function. That means if f of x is some h of x plus g of x, suppose the RHS of our differential equation contains two functions, then you select from the table the corresponding lines on the second column, then write the sum of those two yp's, then do the same process. Let us consider the first question. Solve y double dash minus 3y dash plus 2y equal to 4x square by the method of undetermined coefficients. We know this is a non-homogeneous differential equation with constant coefficient, and we are discussing how to solve it, how to find the complementary function and particular integral by using undetermined coefficient. Okay. Now, I am dividing the procedure by 4 different steps. In step 1, finding YH. In step 1, we are finding YH. So, first you convert this differential equation in terms of the operator capital D. So, the first term y double dash becomes d square y minus 3y dash. Y dash is dy, so minus 3 dy plus 2y equal to 0. You consider consider this as a homogeneous type. Okay, so instead of 4x square, in the place of 4x square you write 0. Okay, since y is common, you write d square minus 3d plus 2 into y is equal to 0. Always remember write y at the end of the operator. Since this is an operator, write y at the end. Okay, now you find the auxiliary equation. I told you an easy method, in a step for writing the auxiliary equation, that is, you just replace d by m. So, m square minus 3m plus 2 equal to 0. This is the auxiliary equation, and on solving m is equal to 1 comma 2, these are the roots of auxiliary equation, and you can see these roots are real and distinct. That means it comes under the first case So complementary function or yh is equal to c1 e raised to x plus c2 e raised to 2x. This is step 1. Now come to step 2, that is finding yp. Now given f of x is equal to 4x square, that means algebraic function, okay, 4x square. Therefore you have to select from the same line yp as k0 plus k1x plus k2x square. Say, let us consider another example. Suppose it is 4x. Then what will be yp? Yp will be k0 plus k1x. Suppose it is 4x cube. Then what will be yp? Yp is k0 plus k1x plus k2x square plus k3x cube. So like that you have to increase the power. So you have to write up to the term containing x square, since f of x is 4x square. Okay, so after selecting yp, we want to substitute yp dash and yp double dash in the ODE. For that, find yp dash. Yp dash is k0 whose derivative is 0, k1x derivative is k1, and k2x square derivative is 2k2x. Then yp double dash is in k1 derivative is 0, 2k2x whose derivative is 2k2. After finding yp dash and yp double dash, we are substituting these in the given equation. Okay, the given equation is y double dash minus 3y dash plus 2y equal to 4x square. So this is the value of y double dash minus 3. See, this is yp dash plus 2 into this is yp, that is equal to 4x square. Now step 3. In step 3, we are equating coefficient of like powers of x. Equating coefficient of like powers of x. See, you see the substituted equation. It contains constants, term containing x and term containing x square. So first we are equating both sides, the coefficient of x square on both sides. Here coefficient of x square, see where we have x square, see 2 into k2 x square contains only this term containing x square. So x square whose coefficient is 2k2, and on RHS x square whose coefficient is 4. So on equating both sides, we have 2k2 is equal to 4, and from this k2 is equal to 2. So we obtain the value of k2. k2 is equal to 2. Now we have term containing x. So take coefficient of x on both sides. Look at the substituted equation again. You collect the various coefficients of x. Here we have x term. That means minus 3 multiplied with 2k2. The coefficient of x here is minus 6k2. So first term is minus 6k2. Then here we have a term containing x, that is 2k2. So 2k2. And on RHS we don't have any term containing x. Therefore RHS is 0. So from this already we have k2 is equal to 2. So on substituting k2 is equal to 2, we have k1. On simplifying, k1 is equal to 6. So now we obtained the value of k2 and k1. And the remaining is finding the value of k0. Okay, k0, for getting k0, you collect the constant terms on both sides. Here the constant term is 2k2, and here minus 3k1, and here plus 2k0. And on RHS we don't have any constant. Therefore RHS will be 0. Okay, so on equating constant term, 2k2 minus 3k1 plus 2k0 equal to 0. Substitute values of k1 and k2 already we obtained. Now k2 is equal to 7. Okay. Therefore yp is equal to, already we assumed yp as k0 plus k1x plus k2x square. On substituting k0, k1 and k2, final yp will be 7 plus 6x plus 2x square. Now step 3 over. we have step 4. In step 4, writing the general solution. We know general solution y is equal to yh plus yp. Okay. So in this case, it is c1 e raised to x plus c2 e raised to 2x plus 7 plus 6x plus 2x square, and this gives the complete solution of the given differential equation. And I hope you all understood this method. Thank you.